Good morning, this is Dr. Sailaja, working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today, in this lecture, we are going to solve some problems on Poisson distribution. And we know the properties of Poisson distribution to find the probability of x equal to x e power minus lambda into lambda power x by x factorial. So this is the probability density function of Poisson distribution, where lambda is the parameter of Poisson distribution and it can be defined as lambda equal to np. So here n is number of times the random experiment done and p is probability of success in that experiment. And moreover, here in Poisson distribution, n is very large and the probability of success is very small, so that lambda is a finite value. So these are all properties of Poisson distribution to find the probabilities. So here we solve some problems in Poisson distribution. Here 2% of the items of a factory are defective. The items are packed in boxes. What is the probability that there will be 2 defective items, at least 3 defective items, no defective item in a box of 100 items? So each box contains 100 items. So n is equal to 100. And 2% of items of a factory are defective. So here the probability of a defective item is given. So p equal to 2%, which is 0.02. And we know the values of n and p. And we know that lambda equal to np. And lambda is parameter of the Poisson distribution. So here lambda is n into p. So 100 into 0.02 means 2. So lambda is a finite value. So lambda equal to 2. If we know the parameter lambda in Poisson distribution, we can find the probability at any value of x. Now the first question is, what is the probability that there will be 2 defective items? 2 defective items means exactly 2 defective items. So x takes the value x is equal to 2. So probability of x is equal to 2. Lambda equal to 2, x is equal to 2. So we take the formula to find the probability at x equal to 2 is p of x is equal to x is e power minus lambda into lambda power x by x factorial. This is probability density function of a Poisson distribution to find the probability of x value. So here e power minus lambda means e power minus 2 into 2 square x is equal to 2 by 2 factorial. After simplification, we get the probability is 0.271. So what is the probability that there will be 2 defective items? Out of 100 items, what is the probability of there may be 2 defective items out of 100? So there is a 0.271 or 27% chances are there. Out of 100 items, 2 defective items are there. Similarly, the second question is, what is the probability of at least 3 defective items? At least 3 means maybe 3, x is equal to 3 or x greater than 3. So that's why x is greater than or equal to 3. X takes the values from 3 to at least 3 means minimum value is 3 and maximum value is the number of items contained in the box. That is the maximum value. So we know that the box contains 100 items. So n is equal to 100. So what is the probability of At least 3 defective items is probability of x greater than or equal to 3. Now x greater than or equal to 3 means 3 is the minimum value, 100 is the maximum value. So 3 to 100, probability of x equal to 3 plus probability of x equal to 4 plus probability of x equal to 5 plus until probability of x is equal to 100. Since the box contains total 100 items. So at least 3 defective items means 3 defective or 4 defective or 5 defective up to 100 defective items. So what is the probability of 3 or more defective items? So instead of finding all these probabilities, probability of x equal to 3, probability of x equal to 4, probability of x equal to 5 and so on, probability of x equal to 100. So instead of finding all these probabilities, we take the total probability is 1. So 1 minus what values of x are missing. So we take those probabilities. Total probability 1 minus probability of x equal to 0, x equal to 1, x equal to 2. So this probability of x greater than or equal to 3 is equal to this value. So in this probability, only x values missing are 0, 1, 2. So if we subtract 0, 1, 2 probabilities from the total probability, that probability is equal to the required probability. So here 1 minus probability of x equal to 0 plus x equal to 1 plus x equal to 2. Now we find these 3 probabilities and subtract from 1. After that, after simplification, we get 0.323 is the probability. That means there are 32.3 percentage of defective items, at least 3 defective items that box contains. The last question is no defective item in a box of 100 items. That means all 100 items are good items, no defective item. So no defective means x takes the value x equal to 0. X equal to 0 means no defective item. So we find simply e power minus 2 into 2 power 0 by 0 factorial, where 0 factorial is 1. So e power minus 2, the probability is 0.135. So 13.5% chances are there that the box contains no defective item. See the next example. For a Poisson distribution, probability of x equal to 1 equal to 2 by 3 into probability of x equal to 3. Find probability of x greater than or equal to 1. Probability of x lies between 2 to 5. So here the relation is given. Probability of x equal to 1 equal to 2 by 3 into probability of x equal to 3. So to find the probability in Poisson distribution, we must know the parameter lambda. Then only we can find the probability in Poisson distribution. So from the given relation, we can find the parameter lambda. Probability of x equal to 1 equal to 2 by 3 into probability of x equal to 3. This is a relation given. And we know that the probability density function of Poisson distribution is e power minus lambda into lambda power x by x factorial. So x equal to 1 means e power minus lambda, we don't know the value lambda. So we write it as it is. E power minus lambda into lambda power x value is 1, lambda power 1 by 1 factorial, which is equal to 2 by 3 into x equal to 3 means e power minus lambda into lambda cube by 3 factorial. Both sides cancel e power minus lambda, then do the cross multiplication. If we solve this equation, we get lambda square equal to 9, lambda equal to root 9, lambda equal to 3. And moreover, lambda is always positive value. So we take the positive value, lambda equal to 3. Since lambda equal to NP. N is number of times the experiment done, P is probability. both values are positive. So that's why lambda also positive. So lambda equal to 3. Now this is the parameter of Poisson distribution, lambda equal to 3 after solving this relation. Now we find the probability from this parameter. Probability of x greater than or equal to 1. We don't know n value also. So here probability of x greater than or equal to 1 means x takes the values 1, 2, 3 and so on. So instead of finding this probability, we take again the total probability 1 minus whatever the value of x are missing, we subtract that probability. That is probability of x equal to 0. So this probability is equal to the required probability. So 1 minus p of 0. So 1 minus e power minus lambda, that is. So after solving this 0.9502. So this is the probability of x greater than or equal to 1. Similarly, we can find probability of 2 less than or equal to x less than or equal to 5. That means x takes the values between 2 and 5, including 2 and 5. So the range of x lies between 2 and 5. So x takes 2, 3, 4 less than or equal to 5. So that's why we include 5 also. So e power minus lambda. The probability density function is this. So we can take e power minus lambda common. Then simplify this. We get the probability 0.7169. So this is the probability of x which takes the values 2 to 5. Another important probability distribution is normal distribution. Here binomial and Poisson are discrete probability distribution, whereas normal distribution is a continuous probability distribution. So here x is a continuous random variable and the probability density function of normal distribution is defined as f of x is equal to 1 by sigma into root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square. And x takes the values minus infinity to infinity, since here x is continuous random variable and 0 otherwise. So this f of x is called normal distribution, probability density function of normal distribution. So here x minus mu by sigma is a normal variable z, and the normal variable capital X follows normal distribution with the parameters mean mu and variance sigma square. These are all properties of normal distribution. So here the normal curve, this is the normal curve y equal to f of x, is a bell-shaped curve. So the total area under this normal curve is 1, or in area means 100%. If it is in probability, we take it as 1. So the total probability is 1, and this normal curve is symmetric about the mean x is equal to mu. That means the area under the normal curve equally divided into 2 equal parts on either side of the mean. So left of mean is the probability 0.5. On right of mean the probability is 0.5. So the total probability under the normal curve is 1. And x takes the values minus infinity to plus infinity. And this curve never touches x-axis. It extends minus infinity to infinity. So the area is divided into 2 equal parts. So that's why 0 to infinity the area is 0.5. Minus infinity to 0 the area is 0.5. So 0 to infinity, half of the area, that is 0.5. And in normal distribution, mean equal to median equal to mode. That means these coincide at the point x is equal to mu. Mean, median, mode. And this z is a standard normal variable x minus mu by sigma. This is also normal variable only. And here we have different cases to find the probability of a normal distribution for a given x values. So here we find the probabilities in particular range of x or in particular interval of x. So that is x belongs to a comma b. This is the interval. Since here x is a continuous random variable and x follows normal distribution with the parameters mean, mu and variance sigma square. So if we know the mean and variance, we can find the probability of a normal variable at any interval of x. So we see different cases or formulas to find the probability in different regions. So case 1, if Z1 and Z2 are opposite side, that means Z1 is less than 0 and Z2 is greater than 0. What is the probability of this area? Then we take area, always we take from mean, that is 0 to Z1 and 0 to Z2. So this can be represented as area of Z1 plus area of Z2. So the probability of Z, where Z is a normal variable and which lies between Z1 and Z2. Z1 is less than 0 and Z2 is greater than 0. So always we indicate Z1, draw a vertical line to the left of mean and Z2 to the right of mean, a vertical line. So in between, that means Z values lies between Z1 and Z2 means this is the area. Now we find the probability of x lies between Z1 and Z2. So here, always we take the probabilities from 0 to, that means mean 0. Standard normal variable Z also follows normal distribution with mean 0 and standard deviation 1. So these two are fixed values in standard normal variable Z. So that's why mean mu equal to 0 and standard deviation is 1. So area of Z1 plus area of Z2. If we add these two areas or probabilities, then we get the required probability that is lies between Z1 and Z2. This is the first formula. Similarly, if Z1 and Z2 are on same side, so here Z1 is greater than 0, Z2 also greater than 0. So draw a vertical line Z1 to the right of mean and Z2 also to the right of mean since both are positive values. So that's why to the right of mean Z1 and Z2. So what is the probability of Z which lies between Z1 and Z2 means this is the area or probability. So what is the probability of Z between Z1 and Z2? So again, here also we take that probability or area from 0 to up to Z2. We take up to Z2, 0 to Z2 minus, subtract this area. Subtract this area, that is area of from 0 to Z1. So this total area is 0 to Z2. If we take the total area 0 to Z2, subtract 0 to Z1, then we get the required probability of Z which lies between Z1 and Z2. This is the required area or probability. So area of Z2 minus total area is area of Z2. That is, it is understood by 0 to Z2 minus area of Z1. It is also understood by 0 to Z1. Then we get the required probability Z1 to Z2. So this is the second case. Third formula is probability of Z less than or equal to Z1. Suppose Z1 is greater than 0. Z1 is greater than 0 means we draw a vertical line to the right of mean. So this is Z1 which is greater than 0. So what is the probability of Z values which are less than Z1 or equal to Z1? Less than or equal to means to the left of Z1. Less than or equal to Z1 means Z values belongs to the left of Z1. So this is the total area or probability. This is the area or probability we have to find. So we know that the total probability 1 is divided into two equal parts. That is, to the left of mean 0.5, to the right of mean also 0.5. So this area to the left of mean or probability is 0.5 plus, and this is the area also we have to add since Z values are less than or equal to Z1. So 0.5 plus area of Z1. Area of Z1 means 0 to Z1. So if we add these two probabilities, then we get the required probability, that means Z less than or equal to Z1. Another case, if Z less than Z1, here Z1 we can take Z1 is less than 0. Z1 is less than 0, then draw a normal curve, draw a vertical line Z1. Since Z1 is less than 0 and the probability of Z values are less than Z1 means, so this is the area. What is the probability of this area? And we know that the total area to the left of mean is 0.5. So we take 0.5, total area to the left of mean 0.5 minus area of Z1. If we subtract area of Z1, 0 to Z1 from the total area to the left of mean, then we get the required probability, that is probability of Z less than Z1. So these are all different formula to find the probability for a given range of X or for a particular interval of X values in normal distribution. Now let us see some examples. If X is a normal variable with mean 30 and standard deviation 5, find the probability of 26 less than or equal to X less than or equal to 40. That means X belongs to in the interval 26 to 40. So to find the probabilities in a given range or in a given interval of X, first step is always we convert the normal variable X to the standard normal variable Z. For each X value, that means the lower limit of X is 26, the upper limit of X is 40. So what is the corresponding standard normal variable of these two X values? That means we are reducing the normal variable X to standard normal variable Z. Then we find the required probabilities. So here what is the data given? If mean and variance are given, of course standard deviation also given. So mean and standard deviation are given. So mean is 30 and standard deviation is denoted by sigma, which is equal to 5. And standard normal variable is Z is equal to X minus mu by sigma. So here X is X1 is equal to 26, X2 equal to 40. So what is the probability of X1 less than or equal to X less than or equal to X2? So this we have to find. For that, we reduce this normal variable to standard normal variable z. So z1 less than or equal to z less than or equal to z2. So if x is equal to 26, what is z1? Z1 is equal to x1 is 26, mu is 30, that is given. Standard deviation sigma also given, that is 5. So if x is equal to 26, then we got z1 is minus 0.8, which is less than 0. If x is equal to 40, this is the upper limit. So if x is equal to 40, what is z2? So again x is equal to 40, mu is 30 and the sigma is 5. Substitute these values. After simplification we get z2 is 2. So this is greater than 0. Now draw the normal curve. Mu equal to 0. This is 0.5 probability on either side of the mean. Then z1 is less than 0 means draw the vertical line z1 to the left of mean. z2 is greater than 0 means draw the vertical line to the right of mean z2. Now what is the probability of z which lies between z1 and z2? So this probability we have to calculate. So again, to find the probability, always we take the formula, that is area of this probability we get from 0 to z1 and 0 to z2. So this value is equal to area of z1 plus area of z2. Area of z1, it is understood 0 to z1. Area of z2 means 0 to z2 only. So here z1 is 0.8. Now we take the tabular values of z. There we get the probabilities for each corresponding value of z. So area of 0.8 is 0.2881 and area of 2 is 0.4772. So if we add these two probabilities, the total probability we get 0.7653. So this area or the probability in between z1 and z2 is 0.7653. So these are different types of problems to find the probabilities in a normal distribution. Thank you.